Welcome to the world of AWS Serverless, where the power of cloud meets the ease of modern development. If you are looking to supercharge your career in tech, mastering AWS services is one of the smartest moves you can make. Why? Because businesses everywhere are migrating to cloud solutions, and they are looking for developers who can build scalable, efficient, and cost-effective apps. Exactly what AWS Serverless architecture is all about. In this course, we are going hands-on with some of the most in-demand tools in the industry. AWS Lambda, DynamoDB, Cognito, S3, API Gateway, and more. You will not only learn the theory, but actually build a fully functioning web app from scratch using real-world technologies. Here's what you will master. Writing JavaScript and jQuery to control dynamic content. Sending AJAX requests to get, post, and delete data. Deploying a website using the full power of AWS. Creating APIs with API Gateway and mapping integrations seamlessly. Managing users with AWS Cognito. Handling signups, logins, confirmations, and tokens. Triggering powerful Lambda functions, and even creating your own Lambda layers. Building scalable databases with DynamoDB, including working with partition and sort keys, and so much more. But that's not all. Every line of code will be explained step by step. I've designed this course to be an easy to follow, heavily commented, and packed with practical examples that will prepare you to deploy real-world solutions. By the end, you'll have built your own public-facing website and gained invaluable skills that you can show off in your portfolio. This is super beginner-friendly, and you'll have the resources you need to succeed, with explanations every step of the way. Let's dive in and get started on your AWS journey. Welcome to the course. Here's what you will discover as we build our project step by step. We will begin by exploring the project's core features, including the website, the JavaScript code, and its AJAX and jQuery components. You'll also see how we use CDNs for API integration and adopt a modular programming style by exporting functions to keep our code organized and efficient. I'll show you how our website is deployed publicly, allowing anyone to access it via a public link. So if I take the link for our website and I copy it, and if I open a private browser, you can see I can access the website. Let's look at the user registration and management. We will learn how to utilize AWS Cognito APIs to register users in our Cognito user pool directly from our program. So if we click sign up for our new user Will, we get the successful registration of Will. We will have our user pool in Cognito, and if we refresh, Will just got added. And we will get a verification code in order to confirm Will's sign up. So that takes us to the next component of our application. We will look at user confirmation. We will see how user confirmation works through a post request to our API gateway, which triggers a Lambda function to insert a record into DynamoDB. So let us confirm Will's sign up. We'll go to the email, copy our confirmation code that we just got and paste it. Confirm user confirmation successful. This sent a post request to our API and API gateway, triggered a Lambda function. So user confirmation is successful. So this triggered a post request to API gateway, which triggered our Lambda function. And if we go to DynamoDB, we will have our table here. And if you go here, you will see that we just inserted our user into our table once they got confirmed. So you will see how all those components work together. We will see user authentication. So we will get to discover how we use Cognito APIs to authenticate users and verify their credentials. So we can log in as Will here using his password. be taken to our Notes app, also designed in JavaScript, and we will learn about the CRUD operations: create, read, update, and delete. Let us look at the adding notes feature. So observe how adding a new note triggers a post request to API gateway, which then invokes a Lambda function to save the note in DynamoDB and refresh the page to display it. So if you look here, this is our notes table in DynamoDB. Next, we can have Will write a quick grocery list. So he will buy apples. And now we see apples got added. And you will see in DynamoDB, we got a new record inserted because it sent a post request to API gateway, triggering a Lambda function to insert the record into DynamoDB. So we can add two more: red and orange. We can look at the deleting notes feature. So learn how deleting a note initiates a request to API gateway, which calls a Lambda function to remove the record from DynamoDB and update the display accordingly. So let's say if we don't need apples, when we click this delete button, you will see we will no longer have apples as one of our records. So we will delete, and apples is gone, and it updated our display. We will look at session management. So we'll see how logging out removes the user token from session storage, and we can re-log in and experience how logging back in restores the user's notes and their previous state, demonstrating how data is persistently stored and managed through these cloud services. So let's go ahead and log out. This is a public link, so I can just take this, Control C, Control Shift P. I can log in. Will can log in again. So this can be done from any computer. That's why I'm doing it in the private browser. We log in. We see our notes. Let's add another item to our grocery list. Let's add ice cream. We can add the note. We can remove oranges and replace the oranges with grapes. Add the note. We can log out. We can come here. We can log back in and see the changes because it is all persisted through these cloud services. So that is the app we're going to build, and we're going to go through plenty of code. You're going to see it all step by step, how we built this app. We're going to make Lambda layers. We're going to go through this JavaScript, see how we use jQuery and Ajax. We use CDNs in order to use the AWS APIs. We learn all about creating functions in Lambda, creating API resources, integration request mapping, how to create tables, partition keys, and sort keys in DynamoDB, all in depth, step by step. I hold your hand at every part of this project. By the end of this course, you'll have a thorough understanding of AWS serverless technologies, how to implement them effectively, whether you're a beginner or have some experience, and we'll walk through everything, breaking down the code and concepts for all skill levels. So let's get started. Okay guys, so the way I'm going to structure these tutorials is first I'm going to show you how to complete the part and have the function of the code and the application working, and then we're going to walk through the code line by line explaining what's going on. So first we're going to open Visual Studio Code. I'll open a new window. So first I'll open a new window. Next I will go into some folder. Now we'll make a new project. I will call this just Notes Tutorial. Well, I'll just call it Notes V4. I'm doing this. It's the fourth time I'm doing this, so I'll go and I'll drag this here. Next, let us make our files. So if we go here, we're going to make our index.html. I add plenty of comments explaining what is going on here, but we can walk through the code briefly. So we'll go here and make our index.html file. We'll just copy paste the code and save this. Next, we'll make our CSS. We'll copy paste that. Oh, I made the script here. Yeah, okay, I'll just go line by line. So next, make the script .js. So we'll go here, new file, and copy this. You don't need to copy all the comments. I'm just choosing to do so. So copy this and paste. And finally go to styles. And copy paste all of this. I know I included a bunch of these numbers, so if you want to delete them, I just found out you hold Shift and Alt, and then you'll be able to you'll be able to do column select. So let's delete all of these. Good. And Shift Tab to bring this back and save. Now, if we go to the next step, you'll see use live server in order to test and develop this app. So you can easily download live server if we go to search, or not search, you got to go to extensions, and just if you search up live server, it's already there for me. Just go here and you're going to click the install button, and that's going to simply install live server, and that's all you'll need to do. It's a pretty straightforward install. Once you have it installed, you'll have the option to open the application with live server like this. So now we can view our application. Now this is all just static, has none of the functionalities I demonstrated in the demo at the beginning of this video, but it's the base for our app. Like we can add notes, we can add like whatever, 1, 2, 3, 4, 5, and we can delete them freely, but nothing is stored, nothing is saved. There's no user login, logout functionality, no AWS services. So this is the base. Now let's go ahead and break down the code line by line so you can get a bit of an idea of how we built this app. Okay, so let's break down this code. So index.html, this is a file that defines the basic structure of the Notes app using standard HTML elements. One thing to note is this app uses jQuery loaded via CDN, which we can find right here in this script tag for simplifying JavaScript interactions, especially DOM manipulation. A separate CSS file is linked to handle the styling of this app. We can find this here in styles.css. Let's look at the main elements. So here we have this text area where users will write their note. We have the button with the ID add note. This triggers the addition of a note. There is a unordered list. This displays the list of notes that the user adds. Next we have this script tag, which links to our script.js file, which we will use in order to add functionality to our application. Let's go over that now. This first line document.ready function, it ensures that the JavaScript code inside the function runs only after the entire document object model or DOM is fully loaded. It prevents errors that could occur if the script tries to interact with HTML elements before they exist. The add note.onClick is a line that sets up the event listener for the add note button. When this button is clicked, the function inside is executed. Here the value from the text area is retrieved using jQuery's .val method. The .trim method removes any leading or trailing white space from the note text to ensure only the meaningful content is processed. This if statement, this line checks if the user entered an empty note. If it's empty, another message is shown, and the function exits early, preventing the addition of empty notes being added to the list. This note item variable is a new list item. It is created dynamically using jQuery. This class attribute is set to note item, which is used in the CSS to style the note item. Note item is a jQuery object representing this list item. Note span is a span element. Note span is a span element created to hold the note text. The .text method sets the content of the span to the text of the user, the span to the text the user entered. A span element is created to hold the note text. The .text note text method sets the content of the span to the text the user entered. This delete button is created with the class delete note. The button's text is set to delete. This button will be used to remove the note from the list. This delete button on click is this delete button on click is added to the delete button, which is an event listener, which this delete button on click is an event listener, and it is added to the delete button. It triggers when the button is clicked. The function removes with the .remove the entire note item from the list, effectively deleting the note. Note item.append, the span containing the note text and the delete button are appended to the list item. This builds the structure of the note item dynamically with the text and delete button inside the list item. The noteslist.append. Noteslist.append, the newly created list item, which now contains the note text and delete button, is appended to the unordered list in the HTML. This makes the note visible on the page. Note input.val. After the note has been added to the list, this line clears the text area by setting its value to an empty string. This prepares the input area for the next note the user might want to add. So that'll be the breakdown of the HTML and this script.js file and that completes step 1. So that'll be the breakdown of the index.html, script.js, and styles.css. This completes step 1 of our serverless notes app. I hope to see you in step 2. Thank you, and please subscribe. Okay guys, let's get to part 2. we will add the sign up / user confirmation / login page. This part is pretty easy to execute and will be pretty straightforward. Let's get started. So first, we're going to copy all of this. We're going to go to our Visual Studio, this one. Next, we will create a new file. We will call it signup.html. Next, we will copy paste all of this. We will save it. And if we go to our Notes app here, not this one. If we open up our application in Live Server like this, and styled Notes app, we can add some styling to this app easily. So we will go back to the document and we will add the CSS and we will call it signupstyles.css. So copy all of this, go to our application, create a new file. We will call this signupstyles.css. Copy paste everything. And now if we go back to our application, we have this styled notes. We have this styled sign up sheet or sign up page. Now let's break down this page and go through the HTML really quick just so that we can get a better understanding of it. So you know what doc type is, just declaring that it's HTML. This is the opening tag. This is the head section that contains metadata and links to external resources. We're specifying the character encoding here. This ensures that the web page is responsive and adjusts to different screen sizes. This is the title of our web page that appears in the browser tab. We are including jQuery, the popular JavaScript library for making AJAX requests and DOM manipulation. This links the external CSS file, signupstyles.css. We're styling the page. This is the heading for our sign up section. This is a form for the user to sign up. This is an input field for the user to enter their username with a placeholder text. This is an input field for the user to enter their email with the validation for email format. This is an input field for the user to enter their password. And this is the button to submit the sign up form. This is the heading for the confirmation section, and there are very similar elements found here and here as in the sign up form. And this is all of the styling done for the signupstyles.css page. So that concludes part 2. It's pretty straightforward. Next, we will continue on to part 3, where we will make our AWS Cognito user pool. Stay tuned for that, and thank you for watching. Okay guys, before we start part 3 of making our AWS Cognito user pool, let's learn a little bit more about AWS Cognito. So why use AWS Cognito? AWS Cognito is a service that helps manage user authentication and authorization. It allows you to sign users up, confirm their identity, and securely manage user sessions with tokens. In this project, we are using Cognito to handle user registration and login, replacing the need to manually manage credentials in our own database. Cognito offers user management. This means that Cognito automatically handles the sign up, sign in, and user management tasks. It'll handle security. It provides a secure authentication using industry standard protocols like OAuth 2.0 and JavaScript Web Tokens, aka JWT tokens. It offers scalability. Cognito scales automatically to handle large user bases without additional efforts. What are the problems solved by Cognito? It eliminates the complexity of handling passwords, hashing, and token generation manually. It ensures a secure communication between the user and your services without needing to build custom authentication logic. It reduces the time and effort required to manage users and their permissions across multiple applications. In short, we use AWS Cognito to securely authenticate users, issue tokens for session management, and simplify user management tasks in serverless applications. We are creating a Cognito user pool, which is a secure directory to store and manage user signups, logins, and authentication. This allows us to easily manage users, confirm their identities, and issue tokens for secure access to our serverless application. Our app will connect to this Cognito user pool to handle all user-related tasks such as signups, logins, and managing user sessions. By integrating with Cognito, we add user management functionality to the app without having to build custom authentication logic, allowing us to securely authenticate users and issue tokens for accessing other parts of the app. Now that we have an understanding of Cognito, let's go ahead and make our user pool in AWS. Okay guys, without further ado, let's go ahead and make our user pool in Cognito. I have it pinned here, but you can just type Cognito. So first we will just click create user pool. Next, we will choose to collect the username and email. We will not select this federated identities, meaning that the users will not be able to sign up with Gmail or Facebook. Let's click next. We will keep the Cognito defaults for the password requirements in the password policy mode. We will choose no MFA because if you don't know, MFA just means that when you try to log in, you're gonna get a notification on your phone saying, "Are you logging in?" It's kind of like when you log in from a different device and Google sends you that notification, somebody logged in on your email, but I'm not going to set that up here. We can leave this self-service account recovery enabled, and even though I'm not going to really touch this. And the delivery method for user account recovery message, we're going to choose email only. So we're not going to choose any of these other options. Click next. We will enable self-registration, allow Cognito to send messages to verify and confirm. Send email message and verify email address. We will keep the original attribute active when update is pending. We will select email address for active attribute values when update is pending. We won't add any additional required attributes. We won't modify these custom attributes, and we will click next. So basically step 3, you just left all the defaults. Next, we will send emails with Cognito because I'm not going to set up the simple email service in Amazon and AWS. This will be more than enough for the purposes of this project. Also, by the way, guys, just keep note of the region you create all your resources in. It it's possible you can get an error if you create resources in one region and then another resource in another region. I just keep it simple and I make everything in Ohio or US these two. We can click next. Leave the from email address as a default. This is the email address that will send your confirmation code to confirm your sign up. We will click next. We will create a user pool name. So I'm just going to call this notes v4. You can use the Cognito hosted UI, but I'm not really going to mess with this because we're developing our own UI and using Cognito in the backend and interacting with it through JavaScript and using the APIs made available to us. So you can, if you want to play with this, you can, but it's not going to be really used for our application. And this is the domain that you could set up if, again, you're planning to use the Cognito UI. So you can just put any sort of name here. You could just put domain 227. This is the link that'll be given to you. Next, let's go through the steps to set up the app client. This lets our scripts talk to and interact with AWS Cognito service. So this must be configured correctly. We go with the public client name. Let's create a app client name. App client 227. I do not generate a client secret because I created an access key for one of my users in IAM, Identity Access Management Service, to allow the script to access Cognito. For now, this is okay for the purposes of making this project and learning and testing. We can create a callback URL. It doesn't need to be real. You can just put whatever you want here if you wish. This is basically the URL that the user gets sent to after they log in. We will click next, and here we review and create, and we will create our user pool. So just the main thing to note is that the main thing is that you choose public client here in the application client settings. And I don't make a client secret, but we're going to handle that in another way later on. So we just create our user pool. So that concludes part 3, where we learned about AWS Cognito and we created our Cognito user pool. Stay tuned for the next part. Thanks for watching and please subscribe. Okay guys, so let's continue on with part 4 where we will code the sign up process of our Notes app. Let's go to IAM, where we will create a new user we will use this user in order to create our access key and secret key so that we can interact with the Cognito service from our program that we will code. So we will go and click create user. We will create a username. I will call it notes user 4. I will not click this and we will click next. We will attach policies directly. Type in admin. We will select administrator access. This is good because this makes it so that we do not have to worry about running into permission issues if we give the administrator access to this user. We will click next. We will click create user. Next, we will go to this user. We will click access key and we will create an access key. You'll select a reason, give a description, notes access key. We'll make sure to copy this and we will use it later. Next, we will go back to our code. We will make a new file called auth.js. First, at the top of signup.html, we will add these two script tags. This one right here. And this right here. Next, we will scroll down to the next part of the document and copy this part of the code onto auth.js. So, as you can see here, as I mentioned, guys, this is all included in the document. So, we scroll here, we copy this from the document. If, as I mentioned several times throughout the video, now we got to change a couple things about this chunk of a code. So this is where we configure our region. So for me, that's US East 2. This needs to be changed to the user pool and client ID that you created earlier. So we will go to AWS, go open Cognito. Go to Notes v4, which is our user pool that we created for this tutorial. Copy this user pool ID and paste it into our application. Then we want to get our client ID and paste that into our application. So we can find that if we go to app integration, and here we will find our client ID. Now let's go back and paste that. Next, we want to create our secret key, our access key and secret key in order to initialize the AWS SDK and be able to interact with Cognito service from our program. We will go here. We created a user, we created the key. Now we will copy this key and place it in our program. Replace the access key with the one you copied and replace the secret key with whatever is here. Also, guys, don't try and use the key that I gave you in the code or in the document. That key will be disabled and will not work for you. You need to use your own key. So that's all that we need to change, or that you will need to change for yourself. Next, we will scroll down and we will add this function. We will click save and we will add this function. This function will handle the sign-up process. I will be explaining it once we get the program working. We will go back and we will copy paste this script back into our signup.html. So we will go here and copy paste this script tag, which imports the function that we just made into our HTML in order to use in our application. We will click save, and now, because sometimes you need to reopen the live server when you make these changes, so I'll open it again, which is the one I just copied. Click sign up. We got the a message saying successful registration. Now, if we go to Cognito, we can go to user pools and we will see if we hit refresh for our users, we will see Tim is there. Next, we will see that we got mailed a verification code right now, 2:04 p.m., 2:04 p.m. And we will use this code when we complete the confirmation step of the program. So now you see that we successfully can register users and they get added to our Cognito service in the user pool. Now let's learn more about the code and what we actually did. At the beginning, we added this line. So here we are adding the AWS SDK for JavaScript, which provides the necessary functions to interact with AWS services like DynamoDB, S3, and more. This script must be included before using any AWS-related functionality in the app. Here we included the AWS Cognito Identity SDK, which helps handle user sign-up, sign-in, and user management features. This is crucial for integrating authentication via AWS Cognito in the Notes app. We set the AWS region to US East 2, which specifies where my AWS resources are being hosted. Next, we create an object called pool data that stores the configuration for the Cognito user pool. User pool ID is the unique identifier of the Cognito user pool where users are stored. Client ID is the identifier for the app client that connects to the Cognito user pool. This client ID is used in my app for authentication and it doesn't need a secret key. Here we are initializing the AWS SDK configuration. Again, we specify the AWS region where the Cognito resources are located. Here I'm setting up the credentials for the AWS SDK so it knows who is making the requests. In practice, we probably don't hard code the credentials. We would use IAM roles or environment variables for security, but for the purposes of this project, this is fine. Here we create a service object for interacting with AWS Cognito Identity Service Provider. This object allows me to use various Cognito related functions such as the sign up, sign in, and user management. This line creates a Cognito user pool object using the pool data defined earlier. This object allows interaction with the user pool, such as authenticating users and managing user sessions. Now onto the function. This is the function that handles the sign-up process when the user submits the sign-up form. This prevents the default form submission behavior and allows us to implement the custom sign-up logic. Here we are getting the user provided values from the HTML form fields. We are getting the username entered by the user, the email, and the password entered by the user. We create an array to store user attributes such as email required by Cognito during sign-up. We create an object that represents the user's email attribute. This is the name of the attribute, and this is the actual email value entered by the user. We create a Cognito user attribute object to define the email attribute for Cognito. We add the email attribute to the attribute list, which will be sent to Cognito. We call the signup function from the Cognito user pool to register the user. The parameters for this signup function are username, password, attribute list, for example, email. The null represents optional parameters and a callback function. If there is an error during the signup, we will show an alert with the error message. If the signup is successful, we display a success message and prompt the user to check their email. Finally, we go back to signup.html. This script is marked as a module, allowing the use of imports and exports between JavaScript files. We import the handle signup function from the auth.js file. This function is responsible for handling the signup logic. We attach an event listener to the form with the ID signup form. When the user submits the form, the handle signup function will be called. The submit event is triggered when the form is submitted, preventing default behavior and allowing custom processing, such as the Cognito user signup that we programmed. So that concludes part 4, coding the signup process. Next time we will continue on to part 5, where we code the confirmation process for our app. Stay tuned for the next video. Thank you for watching, and please subscribe. Okay guys, so let's get started on part 5, coding the confirmation process. So here we will insert a user into DynamoDB after they complete the confirmation process. So we are going to send a post request to API Gateway with the email, username, and user ID. The Lambda function will get the email, username, user ID, and will insert that data into DynamoDB. So let's get started. First, we'll create the DynamoDB table. So we'll go to AWS, and for you don't have anything pinned, so you can easily search up DynamoDB. We will create a table. We will give the table a name, so this will hold our users. So we'll just call the table notes. Users v4, because this is the 4th time I'm doing this. Now, next, we will create a partition key. The partition key will be called user ID. For those of you who don't know, a partition key in DynamoDB is a unique identifier for each item in a table. It ensures that no two items have the same key, and DynamoDB uses it to distribute data across partitions for efficient access. In this case, user ID is the partition key, meaning each user will be uniquely identified by their user ID when added to the table. This will be used to determine where the data gets stored across the partitions. And the partition is just where we store the data. Next, we will select Customize Settings. We will turn off auto scaling so that we don't get charged a bunch of money. And we will just select one provision capacity unit for reading and writing. That will be all. And we will click Create Table. Next, we will create our Lambda function. So once again, go to the management console. We will click Lambda. We will click Create Function. We will give the function a name. I'll call my function insert user underscore post v4. We will select the Node.js runtime, x86 architecture. and we won't do anything for these advanced settings, and we will click create function. Next, we got to do a couple things to set up our function so that it works correctly. First of all, our DynamoDB, our Lambda function will be inserting data into DynamoDB. So we need to edit the permissions our Lambda function has. Otherwise, it will get a permissions error because it won't have access to DynamoDB. In order to do that, we go to configuration, go to this role name. So we will modify the role name given to this function. Open this in a new tab. This takes us to the IAM console. Next, we will add a permission, attach policy, and we will type Dynamo, and we will select this Amazon DynamoDB full access option right here. We will click add permissions. There. So now our function has full access to DynamoDB, so we won't get any sort of permission errors when it tries to write to DynamoDB. So one other thing we need to do is make our Lambda layer. So you have two options for this. I'll also zip up this Lambda layer and offer it to you guys as a download, or you can make it with me. It's really quick. For those of you who don't know, a Lambda layer in AWS Lambda is a way to package and share common code or dependencies across multiple Lambda functions. Think of it as a zip file that contains libraries, custom code, or runtime dependencies which your Lambda functions can use. You can add this layer to your Lambda functions to avoid duplicating code and manage dependencies more efficiently. So let's get started making our Lambda layer. So first, we will open VS Code, and we can just open a brand new window, or I'll just make a new folder. I'll go into Notes V4 I've been doing with the project here. We'll create a new folder. We'll call it Lambda Layer. We will drag this here. Next, new terminal. Next, we will type npm init. And we'll just click enter, 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 enter. And this is okay, just asking us a bunch of settings and stuff that get defined in the package.json. Next, we will type npm install AWS SDK. And that's it. Now, again, you need to have npm installed. And for you guys that don't want to go through this process, I will provide this zip file for you so that you don't need to do this. You don't need to do this. You can just download the zip file and you'll have the same Lambda layer I'm using right now. So right now I just made my Lambda layer, and I'll just take this and compress to zip file. So we'll just call this, I'll just call this Lambda layer notes app. So this file will be offered to you guys if you don't want to do this step as a download. So you don't need to do this, but I think it's pretty simple and pretty fast. So now we're going to go to Lambda. So go to Lambda. We're going to go to layers, create layer, and we'll just call this notes app layer 4. We will upload a zip file, and we will go to the zip file that I just created. So together we made this lambda layer. And next, we don't need to specify optional, and we will hit create. Next, we'll take this ARN, this resource, Amazon AWS resource number, and we will go here. We'll go to add a layer, specify ARN, paste that, verify, and we add. So now we added our layer. And later you'll see we need this layer because when we make our lambda function later on in this step, if you don't have that, when you import this, you would get an error. So you need the layer to manage dependencies, as I explained earlier. So we made our lambda function. Well done. Next, we'll create the API and API gateway. So this is going to be pretty fast. We will go up top, go to API gateway. Well, it already took me to create API. So I'll just go to get started. Maybe that's what it'll show you. And then we'll create a REST API. Oh, that's why I didn't show APIs before, because the location got changed. Let me see. Okay, this lambda layer got made in my correct location. This and the lambda function. So keep in mind of the location, because I was thinking I have so many, I've already made several APIs, why isn't it showing? So I like to just keep the location consistent for the entire project. I'm making all my resources in US East 2. So we'll create API, create a REST API, give it a name, we'll just call it Notes App v4. And we'll click Create API. Next, we'll create a resource. We'll call our resource Insert User. We can enable cores. So we named our API and we enabled cores. We will click Create Resource. Notice that we have an options method because we enabled cores. So briefly speaking, cores or cross-origin resource sharing is a way for web browsers to control whether one website can access data from another website. Here's what it does. It limits access. By default, a website can only make requests to the same website it came from. This prevents malicious sites from stealing data. Cores also handles permissions. If a site wants to fetch data from another site, the second site must specifically allow it. It does this by including certain headers in its response to say, yes, this site is allowed to access my data. The third part to cores is headers. These headers tell the browser which sites can access the data, what kind of requests are allowed, and other details. In essence, cores is like a security guard that makes sure a website only gets data from other websites if those websites say it is okay. Next, we will create a method for this resource. So basically, we're defining what to do if a post request hits this resource. So what we want to do is we want to execute the Lambda function that we created together. So we'll go back to our Lambda function and copy this ARN and paste it here. So we see our Lambda function and we can and that'll be all. So we will create method, and we will go, and that'll be all for now. So far we have created our DynamoDB table, created the Lambda function, and created the API and API gateway. Next, we will copy paste this code that will send the post request to our API endpoint. So let's go ahead and do that. So we will go into auth.js and paste our function. So right now it's not ready yet. We will need to change a couple things about this. So first, if we scroll to get user detail by username, we need to change the user pool ID to the user pool that we've made ourselves. So we will go to our Cognito service, go to user pools. We will copy paste this, and instead of this user pool, we will use this. We will use the one that we copy pasted. And once we deploy our API, we need to change the API endpoint to the one that we deploy. Or actually, let's deploy our API endpoint right now so that we can just finish with this step. So first, we will deploy the API, and then we'll redeploy it later. So we'll just make a new stage. We can call this stage prod for production. We will deploy. Next, we're at stages, expand, go to post, copy, paste this, and replace this right here. As always, I will explain what this code does after we have it working. So there's our API endpoint, and you're going to copy paste the one that gets created for you over here. So next, we will so now that we've copied the code that sends the post request, we will go to step 5, which is code the integration request. So in order to do that, we just copy paste all of this. And we go to insert user, we go to our post request under resources. We will go to integration request. We will click edit. We will go to mapping templates, add a template. We need to type in application/JSON and paste our integration request. Our template body for our mapping template for our integration request. Just briefly, if you're not aware, all integration requests is when we send data to our API is going to send that data to our Lambda function. But we need to specify in advance how our Lambda function can read the incoming data. So it needs a certain type of mapping needs to occur between the incoming data and that comes to our API endpoint and the data that gets sent to our Lambda function. A mapping needs to occur between the input into our API endpoint and the output of our API endpoint. So that's where this template body comes into place. But I'll go into more depth of this when I explain everything after we get it all working. So we will click save. So that is step 6. So next, we can just see everything working before we code our Lambda function. So we can go to our Lambda function, and right now, if you don't know, all we are doing is we are going to now confirm the user sign up. So they signed up, now they got an email, now we need to confirm the user. So what we're doing in this function, in essence, is we're sending all of the user data to our API endpoint. So their email, username, and the user ID to our API endpoint through all this code, which will be explained in more depth. And then API endpoint will pass it to our Lambda function, and it'll print it out in the console. We'll just return back to our client the event data we sent to our Lambda function so that you could see everything working. So it'll make more sense when I think when you see everything. So we'll just return event, and we can delete this, and we'll deploy in our Lambda function. So it's updating. Now that's good. And one more thing. We need to enable cores on our API, on our post request. Otherwise it won't work. So we go to insert user, click the resource, enable cores, click options, click post, and click save. Then we click deploy API. So now this cores will be updated to our API endpoint, and we don't need to do any updates in the code because we already copied our new endpoint in the code. So now if you're a little lost, I think you're going to see what's going on. So let's open up, go to our application, click more tools, and click developer tools. And let's do a new sign up. We'll do Tom, sign them up. Okay, that's successful. Okay, so that was successful. Now we'll go to email. We'll go to inbox, and 432, a confirmation code got sent to me. So remember, guys, so far up till this point in our users, Tom just got added to our user pool, but not email verified. So now he's going to become email verified after we enter the code. And also, don't forget, we have our DynamoDB table. So for now, nothing is going to get inputted, but that'll be the last step. But just keep this in mind that this is where the data will go. So let's go and confirm this new user. We'll copy this code, hit copy, go to here. Go to our application, enter the username Tom, and enter the confirmation code. So we're gonna now, just to go through the workflow one more time. Now we're gonna click confirm. Now what's gonna happen is our code on our machine will execute, it'll go into Cognito, go into our user pool that we specified here, and look for Tom. Then it'll see what is Tom's user ID, because all the users, if you don't know, so if you go to Tom, he has a user ID, and this is what is going to be this is our partition key in our DynamoDB table. So it's going to get this user ID. That's what this function does. Then it's going to package that all up in one object, which you could see here, which will have the username, the email that we took from the user pool, and the user ID. So we call this function that we made ourselves to get the user ID and email from Cognito in our user pool that we specify based off the username entered, and we're going to send that to our API gateway. Then API gateway is going to do this integration request mapping to map all this incoming data into data that can be read by our Lambda function. And our Lambda function will return everything that we sent to it. So you're about to see that now. Not now. No saving anything. Wait, why didn't it work? I forgot, guys. So you need to add this script tag, this updated script tag, which adds the event listener for the confirm form button. All of the functions that we defined didn't get added to the button click. So when we clicked the button, nothing was happening. It didn't know to execute the function because we didn't import it or define this event listener. So we need to add this. Click copy and add that to our HTML, and we will paste that here. And you can easily delete these numbers by clicking Alt Shift, and you can do the multi-line column select and delete these numbers. Alt Shift, delete this, and delete this. And we can just Shift Tab this back to make it nice and neat. Save, and now we will try this again. So it never got sent, so we can do Tom's sign up confirmation one more time, copy and confirm. So user confirmation successful. You can now log in. So we'll go to our user pool. Now look, confirmed. Before it showed a no and unconfirmed, just like Kim shows. So now when I click OK, you're going to see the data that we passed to our Lambda function in the console. So see, this is what we are sending to our Lambda function. See, we send this in the body, the confirmed username, Tom, his email, and his user ID. So you'll notice that's the email I used to sign Tom up, and this is the user ID that exists in the user pool, A10B550, and if you go here, it's A10B550C8 at the end, C8, so you know. So I'll go into more depth how that function works, but I hope you understand with more depth what's going on here. So that's what our Lambda function receives. And now the final step is to actually, why did this turn to 14? Our final step is to actually code the Lambda function so that it inserts that data, this data, into our DynamoDB table. So we'll copy paste this and copy this, and we will go here. We'll go to our Lambda function and Control A, Control V. Again, you do the column select. I'm sorry, but it doesn't copy properly. Oh. There we go. Column select is Alt Shift. And then we can just delete all this. And then we can Shift Tab. Okay, so that looks nice. Next, before this thing gets working, you need to find the table name. And you need to change this to the table name that we created. So in my case, it's notes users v4 for me. So I'm going to just place that in so that it's working. Now we will deploy this, you'll see this all working, and then I will walk through the code. Sign him up. He signed up. I don't think I console log anything, but I'll have the developer tools open. More tools, dev tools. Okay. Next, so Joe is here now in our user pool. Oh, in our user pool, you'll see Joe is there. Now I go to my email. If I refresh at 0 minute 4:43, I got my new code. Copy the code. Go to my app, and we are going to confirm Joe. Confirm him. And now we got the object. Oh, wait, it looks like I didn't make my Lambda layer correctly. It seems I don't have the AWS SDK, because if I show you my other folder where I made the Lambda layer previously when I was doing the project by myself, if I open this here, so you'll see there are two folders. This is v3. So you see AWS SDKs in the dependencies here, but here it's not the same. Oh, wait, I don't think I didn't copy the command correctly. I see now. I must have miswrote AWS SDK when I wrote it. Okay. We gotta remake the layer real quick, guys. So let's just close these. We'll just make a new folder. Notes v4. We'll just make a new folder. We'll call it Lambda layer 2. Drag this here. We will open up terminal, npm init. No. npm init. And enter all of this, and npm install, or we should just copy this carefully, npm install AWS-SDK. I think I must have mistyped this, so make sure you type this carefully, guys. And let that install. So now, just to make sure it came out correct, so I see AWS SDK 2.1.2.1687. Before it was showing like 0.0 something, and it installed it in a different way. So now it got installed correctly. No errors. I'll just zip this up again. Once again, I'll provide the working zip file to you guys if you don't wish to do this step, where you can just add it to your Lambda project if you want. To your Lambda function. So, but again, I'm showing you if you want to see how Lambda layers are made. And this is what happens if you don't have the Lambda layer. You'll get that error that it can't find that library, because you can't import libraries in the Lambda functions by default. So this thing is zipping up. Now we'll just call this notes v4 layer 2. Okay, app and notes. Okay, nice. So next we will upload this. We gotta make a new layer, or even we can make a v2. Okay, let's add a second version. Create version. Let's call this fixed layer. Upload it. And go to layer 2. layer 2. See, that's way bigger. Before it was like 1.88 because we didn't even include anything. Hit create. And see, now we have a V2. So we can just copy paste this ARN. Copy. Add layer or edit the layer is what we want to do. Oh, we just want to use version 2. Actually, we don't even need to use the new ARN. So that's good. And deploy, it's deployed. Now let's make a new user. Let's actually just delete these users. Actually, it's a pain to delete them. Disable, delete. Disable and delete. Okay, so we deleted 2 users. We'll just remake Will. And we'll copy our password. And sign him up. Successful. Now we'll go to our email. And copy the code. Okay. Now we confirmed him. I was thinking we're supposed to see the message sent. Great. We see we got the success. Record inserted successfully. And now we are happy. We're very happy. We're very, very excited, guys. Now we have successfully completed part 5, coding up this confirmation process, which is hands down the longest part of this entire series and the hardest part. So if you complete this, really well done. You've completed the hardest part of this project. Now let's go ahead and explain this code. Okay guys, so now that we finished coding the confirmation process, let's go ahead and explain what we did here in more depth. So first we created the DynamoDB table. So as you know, this will just hold all the user information, so the user ID, username, and email. So first we made our DynamoDB table, and this contains the user ID, username, and email of each user. And we did this so that later on we can add more features to our Notes app. So the main thing to note here is user ID is the partition key, and for those of you who don't know, partitions are essentially different storage devices or sections of storage that allow the database to scale horizontally as the data grows. Instead of putting all the data in one place, it gets spread across multiple partitions to handle more data and traffic. In systems like DynamoDB, each partition has its own storage and processing capacity. By using multiple partitions, the database can scale indefinitely by just adding more partitions as needed. This approach ensures high availability and performance, as data can be read and written to many partitions at once rather than overloading a single storage unit. The partition key is what determines which partition a particular item of data gets stored in, helping balance the load across partitions for better scalability. Next, we created our Lambda function. So the things to note here is the Lambda function will be executed when the API gateway gets a appropriate request, and the Lambda function has the code which inserts the data that we sent to API gateway via the post request into our DynamoDB table. So we also made our Lambda layer. The Lambda layer is basically just what lets us import the library. You guys saw when I didn't make the layer correctly that it ran into the error. It didn't know what AWS SDK was, but then we added the layer with the AWS SDK. So the reason why we do that is because Lambda has a limit of how big their functions can be. And this is easy for code reusability and just making it easy to manage dependencies. Next, we coded our post request. So the user, it wants to confirm their sign up. So now they hit confirm, and we need to send the data to our API. It does the integration request and response mapping, and it's gonna send back, send that data, the username, user ID, and email to our Lambda function, which will then be inserted into DynamoDB. So let's go through that code line by line. So we'll go to auth.js and go to our handle confirmation. So this is the function that handles user confirmation after they receive an email with a confirmation code. Here we retrieve the username and confirmation code from the input fields. Here we create an object with the user's username and user pool details. So username, so this is the username of the user being confirmed, and this is the user pool that the user belongs to. We create the Cognito user object using the user data, and here we confirm the Cognito. Here we confirm the user's registration with the provided confirmation code. If there is an error, we will alert it, and we will show an alert, and if it's success, we show an alert. Next, we have this try catch block where we try to retrieve the user's details. So in this case, the email and user ID from the Cognito user pool after the confirmation. And that takes us to this function, get user details by username, which we created down here. So this function retrieves the user details, which in our case is the email and user ID, by the username using Cognito's list users API. Here we will return a new promise, and we define the parameters of the list users API call. Here we specify our Cognito user pool ID for our own user pool that we create. This will be unique to all of you. Make sure you change it. We filter to find the user by their username, and we set a limit to 1, assuming the usernames are unique. We call Cognito's list users API to search for the user by username. If there is an error, we will log that error. Otherwise, if a user is found in the result set, we will execute this block. So here we get the first value from the result, and here we declare the variables to store email and user ID. Here we loop through the user's attributes to find the email and sub. So in this case, which is what they call user ID. So in this case, the attribute.name equals sub. So sub represents user ID. So we extract the email address and we extract the sub, which is the user ID. We resolve the promise with the retrieved email and user ID. If no user is found, we reject the promise with an error message. That brings us back up here. We destructure the email and user ID from the retrieved user details. And now we make a post request to API Gateway to insert the user data into DynamoDB. We specify our API endpoint. Remember, this will be unique for everybody. We specify that we're doing an HTTP post method to send data to the server, in this case, the username, user ID, and email. We specify the JSON format for the request body. And here is our JSON object, which contains 3 attributes: the username, user email, and unique user ID. On success, we will console.log the success message, and if there's an error, we log the error. And if we were not able to successfully get the user details, we log that error and show an alert. So that breaks down this code. Next, we want to break down the integration request mapping. Remember, if you go to API Gateway, you go to post, integration request. We have our integration request mapping that we wrote here. So edit, and you'll see that here. So let's break this down. So in this code, we don't necessarily use all the parts for every integration request, such as the headers, query parameters, or path parameters, because our API may not require all that information. We might not be sending all that information to our API. However, we keep this entire structure intact because it provides a comprehensive template for handling different types of incoming data. This approach allows us to easily parse the body, headers, query parameters, and path parameters in one place, kind of acting as like a one-stop shop chunk of code that we don't need to keep modifying. We're just going to keep reusing this throughout the project because we map the method, we map the body, we map the headers, query parameters, path parameters. So we don't need to keep re-explaining this every time we got to do integration request mapping in this project. So even if we're not sending all the information to our API, we can reuse this code without having to modify it or think too much about what specific pieces we need for each request. So it's flexible, reusable, and it covers all potential request components. So let's break this down. This context.http method fetches the HTTP method used when the request was made to the API, so it helps Lambda function know what type of request was received. So this gives the Lambda function information about how the client interacted with the API. Now let's look at the request body. So this input.json $sign extracts the entire JSON body of the incoming request. So if you send data as JSON, this captures it for the Lambda function to process. This is what we use in this particular API resource. Next is the headers. So this first line, this for each param and params, this loops through each header sent with the request. So inside the loop, each header is accessed with input.params.getParam, input.params.header.getParam, and stored as a key value pair. And this util.escape JavaScript, this makes sure that it escapes any special characters to avoid issues when passing data to the Lambda function. So if you're sending custom headers, they will be captured here and passed on safely to the Lambda function, which we will do later in the project. Next, even though we don't do these in the project, let's just break down some query parameters and path parameters. So query parameters, this first line loops through each query parameter, which are key value pairs that you often see in the URL after the question mark. And this takes any query parameter that we sent and ensures that it got passed to the Lambda function. And a very similar thing happens here with the path parameters. Again, it just loops through the parameters defined in the path and makes sure it gets passed to the Lambda function. So in summary, just to conclude, the big picture idea is this VTL script. So if you don't know, this is velocity template language, and it takes all the data from the request, like HTTP body method. So just to summarize, or just to conclude, the big picture idea is this VTL, velocity template language script, takes all the data from the request, like the HTTP method, headers, body, query parameters, and path parameters, formats it, and passes it to your Lambda function. So it'll ensure that no special characters like quotes break the request, and make sure that everything is neatly structured before Lambda processes it. So finally, we get back and we just add our function and add the event handler to our code to make sure that because I got that error when I tried to execute the code and I didn't add this event handler and import the new function that we made. So we need to make sure we add that. And finally, we got to just add our code for our Lambda function, which inserts the data into DynamoDB. So let's just break this down real quick. We make sure you always deploy if something isn't working. So we initialize DynamoDB document client, which provides a convenient method for working with DynamoDB right here. Also, before that, we imported the AWS SDK, which we were only able to do because we added the Lambda layer. Now, here is the main Lambda function that handles the incoming requests and inserts the data into DynamoDB. Here we create the parameters object that defines the table name and item data to be inserted. So this will be used to execute our query against our DynamoDB table. We specify the table that we are going to be doing our operation on, and this is the item object. This is the object that will get inserted into our DynamoDB table. We go into our event object, which is a default object that we always get in our Lambda function. We access the body attribute. Remember guys, so that's how it'll look like when we actually access the attributes from the integration request mapping. So we use the .body. So later we'll use .headers when we pass header information to our Lambda function. So that's what it looks like. So we pass the user ID, confirmed username, and email. And the reason why it's like that is because that's what we did in our code back here. If you look at auth.js, so see, that's the name of the attributes that we passed in our request in our body, which we access through body and user ID. So that's how we access it, and we're going to insert this. Next, we attempt to insert this item into DynamoDB using the put operation. We use the promise-based method to insert the record, and if this is successful, we return a success response. That's what we got back here, the success. That's what we returned. And if there's an error, we will console.log that. So that concludes the explanation for this part. If you want to review something, I comment out all this code. You can review it. This was definitely the hardest part. If you got past this, give yourself, like, really well done. Give yourself a pat on the back. The next parts are easier, and next we're going to code the sign-in process. Stay tuned for that. Thank you for watching, and please subscribe. Okay guys, so this is part 6 where we will code the sign-in process. As always, we get it working and then we'll go through the code line by line. So first we will add the function that will handle the login. So we will add this to our auth.js file. Copy this and we will go to our file, and at the bottom we will add this new function. You can just add it like that, nothing to change. Next, we go back. We will update our signup.html, and with this new script, and that'll be all. That's all we need to do the sign up process. So you'll notice that was pretty quick. So we will now have, previously we confirmed Will, so now we can have Will log in. So now we will have Will log in, copy the password I've been using, and paste, and it takes us to the previous notes app that we made in part 1 with that basic functionality. So you can just make, none of this is saved, but we're going to code all of this so that it gets added to our table and different users can see their notes. Okay guys, so now let's break down the code and explain what's going on in more depth. So this is the function that handles the login process for users. Here we're preventing the default form submission behavior. Here we're retrieving the username and password from the login form. We're getting the username and the password. Remember, we give IDs to these two input fields. So that's how we retrieve based off of the input field. We create an object containing the username and password for authentication. We create an authentication details object required by AWS Cognito to authenticate the user. We define the user data, which includes the username and user pool. So remember, this is specific to you. and we create a Cognito user object that will be used to perform the authentication. Next, we authenticate the user with the provided authentication details, and we define what happens on a successful authentication. So we console.log success, and we retrieve the ID token, so the JWT, from the authentication result. So JWT just stands for JavaScript Web Token, and here we are introduced to the idea of tokens. So let's look into the idea and understand a bit more about AWS Cognito tokens. So what is a token? So a token is a small piece of data that contains information about the user, like their user ID, email, and other claims. So in Cognito, you typically get 3 tokens when a user logs in. The ID token, which contains user information, such as the username or email, and is used to authenticate the user. The access token, allowing access to certain resources, such as APIs or data. And the refresh token, used to get a new ID or access token without needing to log in again. So why is a token useful? It's useful for authentication. When a user logs in, the token provides their identity. So instead of asking for a username and password each time, you can just send the token to verify the user. It adds a security, so tokens expire after a while, for example, perhaps after an hour. This means that even if someone steals a token, it's only useful for a limited time, so you don't have to store sensitive data like passwords on the front end. And it is stateless, so this token contains all the information, and it is stateless. The token contains all the information the server needs, so the server doesn't need to keep track of who is logged in. This makes things simpler and more scalable. Next, how is the token used? So it'll be stored in session storage. After the user logs in, we store the token in session storage. That way we can access it throughout the app, make API calls, or check if the user is still logged in. And it is also used for API requests. Whenever we need to retrieve user-specific data, such as their profile info or notes, we can use the token in the request, and the API checks the token to verify the user. When the user logs out, we remove the token from session storage. This ensures that they have to log in again if they want to access restricted parts of the app. So by managing the token, we can control user access securely and efficiently. Tokens are essential for securely managing the user authentication and resource access in an application using AWS Cognito. So now that you got an idea of what tokens are, so here we retrieve the ID token, JWT, JSON Web Token, from the authentication result. So now you have an idea of what tokens are and how they're going to be used throughout our application. We log the token out, so that's what this long line of characters is. And we store the token in session storage, as I mentioned, for use in other parts of our app. So then we redirect the user to the home page, in our case, to the index.html after the successful login. And here we define what happens if the authentication fails. We just send an alert. Finally, we update our script in our signup.html to include the new function. We import it here. And we add the event handler so that it executes our function on the click of the appropriate button. And then we get rerouted on a successful login to index.html. So that concludes part 6. And well done. Now our user can successfully log into our Notes app. We've incorporated Cognito, DynamoDB, Lambda API Gateway. We've coded our whole app and added AWS services into it. Now the next step is for our user to be able to see their previously written notes, add new notes, delete old notes, and log out of the app. Really well done, guys, if you got to this part of the tutorial and you're learning so much. Stay tuned for part 7, where we code the GET request process to show the current notes a user has written. Thank you for watching, and please subscribe. Okay guys, now we are on part 7. We are going to code the GET request process to show users our current to show the notes of the user that is currently logged in. So, I mean, I could explain to you, but to be honest, so basically if suppose like Tom logs in and the previous time they logged in, they wrote 3 notes. I don't know, like they wrote their grocery list, milk, and apples. Then it'll show, when they log in this time, it'll show milk and apples. So that's what we're coding in this part. So let's get started. So first we will split, okay, so partition key. So first we have to make a new table which will hold all of the notes that each user writes. So when a user writes a note, it will be stored in a DynamoDB table along with the associated user ID. So they write a note and then that note is mapped to a user ID. So Tom wrote a note and then Bill wrote another note, and we're going to use the user ID to map the note to who wrote the note. So each note will be assigned a unique note ID, and we're going to create this note ID by using a timestamp, and this will identify and order the notes by the time they were created. So the partition key for this table will be the user ID, and this will determine which physical partition the data will be stored in. This allows us to query the table for all notes with a specific user. Next, we have the sort key. The note ID will act as the sort key, ensuring that notes are ordered by the time they were created. Since note ID represents a timestamp, this will allow us to display the notes in chronological order. So you could just quickly think, a sort key is just the way it just determines how within each partition the items are ordered. So just off the top of my head, imagine if we had 2 lines. So we have 100 kids and we want to order the kids into 2 lines, boys and girls, and we want to order them from the youngest to the oldest. So the partition key would be if you're a boy or a girl. That determines which line you go into, and the line is like a partition, and then you could think of the age as the sort key. So that determines within each line where each boy or girl will go, youngest at the front, oldest at the back, something like that. So you could think of it like that if you listen to that. So let's get started. Let's go to DynamoDB and we are going to make the new table. So we will go to tables. We will go to create table. So we'll just call this notes v4. So we'll call this notes v4. That's my 4th. We make the user ID is the partition key, and the sort key will be node ID. We will click the customize the settings option, and we will turn off the auto scaling so that we can provision our capacity units. So basically we stay in the free tier and do not get charged. Estimated monthly cost, we're going to be much lower than that, and that'll be all. So let's create a table. Next, we need to create a new Lambda function and API resource in API Gateway. So we're going to start off with making our new Lambda function, which will handle the GET requests. So go to Lambda. I hope you know how to do that by now. Or whatever, I'll just show you. Lambda. Make sure you're in the correct region. Remember it. And then we'll make a name for this Lambda function. Let's call it get notes score get notes underscore get. So I add this underscore get, so this will be the name of my API resource, and this get is the name of the function, the method, HTTP method it'll be assigned to. So Node.js and x86, we will create this. Next, in the meantime, we can make our new API resource. We will call it get notes. So we'll enable cores, create the resource. We will go here and we will create a method, get method, and we will choose our Lambda function. Yep. That's all. So that's the new function we just made for the GET request. So now when we send a GET request to this API resource, it will trigger our Lambda function. Now we got to do two more things here, otherwise it won't work. We will add a layer just as a default. So because I always use the AWS SDK when I design this thing. So I'll just copy this ARN from my previous function, or you can easily also just go to Lambda, go to layers, and we will go to the fixed layer, version 2, that I created 20 hours ago. So copy this, and you can paste it here, verify. We add it. And we got to also do the permissions, because we're going to do GET requests again. We're going to be retrieving information from our DynamoDB. Now I know some of you are thinking, oh, we could just make one role, but why do we need to keep updating the roles? You're right, you can do that. But I'm going to do this here because I didn't do that. So we'll update this, add permissions. And now we won't get any permission issues for this Lambda function. Next, for the purpose of testing, we'll get rid of this and we will return the event that we will see later, deploy that so that we can just see what we're sending to our Lambda function, similar to how we did in the previous part. And finally, we will add our integration request. This time we will be adding headers, but as I mentioned, even though we don't use all the parts of our integration request, for the purposes of learning, this makes it simple if we just use the same integration request that we learned about in the previous part, because it covers the mapping for all possible inputs that the API can get. So it can get, if we send something in the body, headers, method, query params, it handles mapping all of that for our Lambda function to easily use. So for the learning purpose, we'll just copy paste the whole thing, and it simplifies our process. So we'll paste that here. Is this bracket correct? Yeah. I'll just shift tab this back so that it's a little less. Oh no. I'll just there or there. I'll just click save. Okay, now we got everything kind of set up. It's kind of the base. We haven't done any coding yet. We haven't added to our application. We haven't added to our Lambda function. So let's go to the document and see what we need to do next. So the sign in, we're on part 7. Okay. So we made our DynamoDB table, we made our partition key and sort key, and you can ignore this picture. Okay, next, we're gonna create our new resource, get notes. So we did that in API Gateway. Next, we have to create the code that sends the GET request as soon as we enter index.html. So as soon as we load the page, we gotta send a GET request to this API, which will trigger with the appropriate information, triggering the Lambda function to query our table and give it to us, the client. So let us make that function. So we are going to go to our code, index.html. This is the page which holds our code for this Notes app. And remember, in part 1, we scripted the functionality of this page in script.js. So for now, we're gonna just comment it. That was good for that time, but for the purposes of these next parts of the tutorial, we will just comment all this out. We will not be needing this anymore because we're going to replace it with the functionality incorporating the AWS services. Let us go back here. Let us copy paste all of this. And as always, I walk you through the code after we get this part working. So we will paste that here, paste this code into script.js. And to remove these bullet points, remember Alt Shift, and you can do now column select if you have Windows. If you have Mac, just search up how to do column select in Mac. And then we'll just Shift tab back. Next, we have to replace this URL with our API URL. This will be unique for every single one of you. Let us go back to our API. First, we need to deploy this, but before we deploy this API, in order to replace the URL, but before we deploy it, we need to go here and always enable cores. Otherwise, we will get an error. Click Save, and we will now deploy this API to our production so that we get a link to here. Copy this, and this will go into our code. So we replace this URL with our copied URL. Now when the page loads, we call our initialize notes function. So it'll show the notes made by a user. This code initializes notes for a user when a document is ready by retrieving an ID token from the session storage. If the token exists, it decodes the token to extract the user ID, which is then sent to as a header in an AJAX request to an API endpoint. The API response contains the user's notes, which are displayed by appending each note's text and ID to a list element. If there is no ID token, it logs a message indicating no token was found. So in API Gateway, we do our standard integration request mapping, so we already did that, but we also add this in the cores, otherwise we get this error. So first we'll just add this, and then again I explain later. So just go to here, go to resources, go to get notes, go to enable cores. I know we're doing this for the second time, but I went a little bit out of order for the instructions. So here you see this content type AMZ token. We need to add one more because we're sending a header. So we need to add this user ID. So you see access control allow headers. There are all of these. We need to add one more header, which will be user ID, because we're going to send this header to our API and it needs to be able to know that in advance. So now we're gonna, otherwise we'll get an error. So click save, and you're gonna notice if you go to the options method and you go to method response, you will, or integration response, you will see allow headers, method response header access control allow headers, and you will see user ID has been added. So this is very important. Now we need to deploy this, otherwise our changes won't take effect. And make sure you do this, otherwise the project will not work. And it'll make sense when I explain it later in the explanation part. Let's get this working. Now finally, we just got to code our Lambda function. So we're going to take all of this and we are going to copy it. Go to here, go to get notes, and we are going to paste it. Alt, Shift, and then click. Oh, wait. Alt, Shift. No. There we go. Alt, Shift, select. Rid of that. Shift Tab. Deploy. Make sure you change this to the name of your table. So in this case, I made my new table's name Notes V4. So we got to just change this from Notes V3 to Notes V4. Deploy. And this will be unique to you, unless if you name it exactly the same way I name it. Next, we need to add the function that'll display the notes in our app. So this is just simply copy pasting this into our script.js. Copy this and we can paste it down here. Save. And now the next step. Now the final step, because nothing will show if you think about it. Nobody has written any notes. So how are we going to test if this works? So we're going to go into here. So currently we have two tables. We have notes users v4, which should have, and if we explore items in here, Will should be in here. So currently we're logged in as Will. So we're going to copy Will's user ID and we're going to give Will, let's suppose Will wrote some notes the last time he logged in, even though he didn't. And we kind of have to do it this way because we don't have the ability to write new notes to the database, so we're manually creating a note. So we can put any node ID. The most important thing is the user ID, and we got to add the actual attributes. So the attribute for this can be note text is according to my code, I call it note text. So make sure you call it note text or whatever you want according to or you could change these values accordingly. Otherwise the Lambda function will run into an error. So I call this third attribute note text, and let's just call this first note. And we will create the item. So this is a value in our notes table. We have deployed everything else. We have deployed this API with the changes. So now, if Will logs in, he should see that new message for him. So we will log out and we will log in as Will. And you'll see first note is there. So now we got this part working. So now the users will see all the notes that they have previously written from their previous session. So now that now you understand everything that's going on, we will walk through the code, and I'm sure you guys have many questions. So let's start walking through the code, and you will understand everything in depth, what we did in this step, so that you can easily carry on to the next step. So let's explain what we did in part 7 in more depth so that you can easily follow along. So first, we made the new table, which is going to hold all our notes. As I mentioned, the partition key will be user ID and the sort key will be node ID. So the partition key helps us determine who wrote the note, like who does this note belong to, and the sort key will sort the notes based off of when they were entered, because we'll use timestamp to create the note. The note ID will be used as a sort key because we will use a timestamp to create the node ID, which will allow us to sort all the notes based off of when they were entered, from newest to oldest, or however we choose. So remember guys, the partition key just determines which partition receives the data, and sort key is what will sort the data within the partition. So I put these pictures, ignore this one, and now we have our function we made our Lambda function and our new resource and API gateway. So first we will go over the function which sends the GET request to our resource that we have created in API gateway. So let's go over this function. So we are here in script.js. Remember, we include this in index.js. When the document web page is fully loaded, the initialize notes function will be called. Here we are retrieving the ID token from session storage, which is stored when the user logs in. We check if the ID token exists in session storage. We split the ID token into its 3 parts: header, payload, and signature, and decode the payload. We decode from base 64 format. We convert the decoded payload into a JavaScript object. Here we are extracting the sub claim from the token. So remember, sub is their way of calling the user ID, as shown within variable name. And this represents the user's unique identifier. And here we are ensuring that the user ID is a string. Next, we send an AJAX GET request to the API gateway to retrieve notes from the current user. Here we specify our API gateway endpoint. Remember, this will be different for all of you, so make sure you copy paste your own endpoint. This is the HTTP method we specify to fetch the data. This is the format that we expect from the request. Here we are adding our custom header, user ID, and it is sent to identify the user making the request. On success, this is the function that will be executed if this whole request is successful. We log the API response. We reference the HTML element where the notes will be displayed, and we clear any existing notes. Next, I will get back to this, but in more depth, but we loop through the response, which would be the list of notes, and display each note on the web page. So we call our display note function, which I'll cover later, to display each note. This function runs if we encounter an error in the request, and we log the error for debugging. If no ID token is found in session storage, we log a message. So that is the initialize note function, which will send our GET request. Now moving on, I mentioned we had to modify our API gateway options method to include this user ID. Now you just saw, guys, that in our function we send a custom header, user ID, to our API gateway. But why do we need to modify our core's options method in order to accommodate for this? So we went to API gateway, and remember we had to go into get notes, and okay, I made a mistake, guys. So this was supposed to be made under the root path, but I made this resource under the insert user path. Okay, so that was a little bit of a mistake. It's not a big deal, but it was supposed to be made under the root path. Like if I show you my other API, it's supposed to look like this, all under the root, not under this insert user. Okay, well, I'm too lazy to go back and fix it. How do I? Okay, when you make this, you're supposed to create when you make your resource, make sure you create it and you select the root path, not insert user. I made that mistake, but whatever. It doesn't really make a difference. The only real difference it'll make is in the resource. The only difference it'll make is in the invoke URL. So if I would have done it properly, you'll see that it has insert user and then get notes. But if I would have done it properly, it would have just been prod get notes. So it's not a big deal, but I just noticed I made that mistake. And I guess if you're following along, you made that mistake too, so sorry. But the thing I wanted to point out is, if we go to integration, if you remember here, when we went to enable cores and we added user ID here, and that shows up here in the integration response under the method response allow headers, and we now added our custom header. So we're sending a custom header in our GET request to API gateway. So what does all of this mean? So when you remember, guys, when you send a request from your web app to an API, the browser needs to make sure it's safe to do so, especially if the API is on a different domain. This is controlled by CORS, cross-origin resource sharing. If you're using a custom header like user ID in your request, the browser first sends a pre-flight request to the API to check if it's allowed to use that header. If that API's core settings don't explicitly say that the user ID header is allowed, the browser will block the request and you get a CORS error. To fix this, we needed to update the API's CORS configuration to include the user ID header in the list of allowed headers. This way, the browser knows it's okay to send that header and your request will go through without errors. So next we have our Lambda function. So let's break that down. Get notes underscore get. So again, you have to make sure you have your Lambda layer, otherwise this throws an error, which I will provide to you. Next, we initialize the DynamoDB document client, which provides a simpler API for working with DynamoDB. We extract the user ID from the headers of the incoming event. So remember, guys, we do all that mapping, integration request mapping here. So this time, last time we did event.body, this time we're doing event.headers because we're sending information in the header. And we do .user ID because in the code, that's how we specify this attribute with the user ID. So I hope you're seeing the pattern of what's going on. We're going to do this then for the next features we implement, so you get to see it a little more. Next, we will define, there's this try catch block, and we define the parameters for the DynamoDB query to retrieve notes for the specific user ID. So right here, this is the name of the DynamoDB table where the notes are stored. This is the condition to match the partition key. So we're saying if the user ID is equal to the incoming user ID that we sent in the GET request. Here we have to map this placeholder user ID to the actual DynamoDB attribute user ID. I chose to add that in these parameters. And here the value for user ID is the user ID variable from the event header. So this is the condition, and here we just got to map the placeholders in these two lines. Here we perform the query operation using the defined parameters. We initialize an empty array to store the nodes fetched from the DynamoDB table. Here we are looping through each item, in this case note, that's returned from the query result. Then we push each note into the notes array with the desired structure. So here we are pushing the user ID of the note, the unique ID of the note, and the note text. And here we return the notes object once it is fully constructed. Then we have the catch part of our try catch block, which if an error occurs during the query, we log the error and return a 500 status code. And for some reason I still have this return event, which is not needed. Even they say this is unreachable, so you can delete that, or don't delete the bracket if you wish. So deploy. Now that's the Lambda code. I have the final chunk, which is the display notes function. So this basically formats the object and displays it in the nice neat list of notes. So I'll just log in again. So that display notes displays the notes that we retrieve in the nice neat list. So this is our, what do you call it? This is the ID token, the JWT, JSON Web Token, and this is what gets returned from our function, our Lambda function. So we just returned the one note object back from Lambda to here. I console log it when I was developing it. Also good for your guys learning, so you could see what we are getting returned when we sent that GET request. So we just have one object currently. I mean, if you add another one, so let's duplicate. We can duplicate this. Oh, not edit. We can duplicate this item, and we can just call it 2, and we can call it a second note, and we can create this item. And now if I refresh my app, we'll see the 2 notes. So that array will change, and you can see the 2 notes just for your guys' showing. And let's walk through the display notes function. So it's the final piece. We're looping through what we get back, and for each note we execute our display notes function. So what's going on here? So we get a reference to the HTML element with the ID notes list. We create a new list item element to hold the note. We create a span element to hold and display the note text. So we set the text content of the span to the note's text. We create a delete button for each note with a unique data attribute for identification. This .add class adds a class for styling. .text sets the button text to delete. And here we set a data attribute. Here we assign the node ID to the button as a data attribute. So the incoming node ID gets set as a data attribute to this button. Here we have the event listener for the delete button to handle deleting the note. Here we retrieve the node ID from the data attribute when the button is clicked. Here we call the function to delete the note passing the node ID and the user ID. Here we append the note text and the delete button to the list item. Finally, we append the list item to the notes list. So that concludes the explanation for part 7. In summary, this display note creates and displays a new note in the HTML page. It constructs a list item with the notes text and a delete button. The delete button is assigned a unique identifier through the data attribute and is wired with an event handler that calls the delete note function when clicked, passing the notes ID. Finally, the function appends the constructed list item to the notes list in the HTML document. So really well done, guys. That GET request is undoubtedly the hardest part of these next 4, 7, 8, 9, 10, 11. we're almost done. We're almost at the end of the document. We're pretty close. We're at part 8. We're going to code the post requests, which will give us the functionality to add a new note in the next part. So we're going to next time we're going to code this button's functionality here to add a note. We're going to type a note. We're going to say third, and it will add another note. So thank you guys for watching. Stay tuned for the next video and please subscribe. Okay guys, so let's go to part 8 where we are going to code the add note. Let's go to part 8 where we will code the add note functionality of our app. So when we click this, it'll insert a note into DynamoDB with the appropriate data. So if Will inserts a note, it'll insert a note with his user ID, the note text, and the unique note ID. Let's get that working, and then as always, we explain after. So let's create our Lambda function for this new functionality. And this time I'll create the API correctly when we create the API. So just call this one insert note underscore post. Everything else is the same. Next, we'll go into API. This time, this is what I meant, guys. I wanted to create the resource under the root API. So here, wait, no, not deploy, but create resource under the root resource path. So we will call this insert note and insert note, and we will enable cores, so it'll add an options method for us. See how it's under the root instead of under the other one. So we will create method, or actually let's finish up with the Lambda function. So again, we got to just do what we did before, add the policy, so that because it's going to be running to DynamoDB, otherwise we'll get an error for permission. So add this, that's done. The DynamoDB full access. Next, add the layer. Go to code, add layer, add the layer that we've been always using. So that's this one, this Notes app layer 2v4. By this point, you should know what that is. We click add. Next, we go to API gateway. We select post. We're adding a post method. We want to copy the ARN of the Lambda function. Here we are. And we'll do that after. So we'll click create method. Next, we go to integration request, and we create the integration request, the same one that we've been using for the last 2 parts. As I mentioned, this covered because we're going to be sending some body to our API. It needs to be able to do the mapping so that our Lambda function can understand it. So we got to go back up and go to that integration request, and as I mentioned, I use the same one because it maps body, header, method, path parameters, and query parameters. So it's just good for all scenarios, or a wide variety of scenarios. So in this case, we need it for its body. We're going to add that. Click save. Next, we got to go to API. Next, we got to just enable cores, otherwise we'll get an error. Click save. And finally, deploy this API so that we have the link available when we need to copy that link into our code. So insert note and go to post, and this is what we will use. So a little later. So we did all that premature pre-setup. Now we can actually add our new code, which will send the post request to API gateway. So let's copy paste all of this. This will send our post request to API gateway when we click the add note button. So now it's a quick copy and go to script.js as we've been writing, paste and replace the API endpoint with the one we just deployed. Otherwise, this is unique for everybody, as I always mention. So this is the one we just deployed. Copy, paste. Excellent. Now finally, what's the next step? We gotta write our Lambda function is probably what's it. Yeah, and then we're done. Then it'll be working. So we'll write our Lambda function, which will then insert the note that API gateway passes, and it'll insert it into the users table. So we'll deploy this, and now everything is set up. So we can make a third note, click add note, and you will now see once it refreshes, you got the message sent. Should be appearing. Oh, error. Okay, post mock lambda. Let me see. Post integration request. Oh, I forgot a bracket. Oh my god. I forgot. What the heck. This happened to me before too. Okay, so I forgot one. I forgot the beginning bracket. I knew this would happen. Okay, there now. Okay, so I made an error and copy pasting the integration request where I forgot the first bracket. So that's why all of this was happening. So it wasn't mapping properly, and all. I was getting an API error. So now update that, redeploy the API so that the changes are made will be reflected in our application. They are deployed. Now, third time's a charm. There we are, number 3. So 4, and we can go here. 3 and 4 are there, and we can log out when we get the log out feature. So then we will come here and we will see everything has been saved. So now we got part 8 working. Well done, guys. So now it is the next step where we are going to explain what we did here, and you'll see it's kind of a bit of repetition of what we did before, but let's explain this in depth. You guys will understand line by line everything I did in this step, get it working. So let's get to that. Okay guys, so let's get started on explaining part 8. Okay guys, let's get started on explaining part 8, where we coded the functionality of our add new note button. So let's just go over this step by step, and I'll explain what I did along the way. So we created our new Lambda function. So by now that should be pretty straightforward. We do this first so that when we make our HTTP method in API gateway, we have a method to specify. So this is the one, insert note underscore post. Next, we created our resource in API gateway, and that also by now should be pretty straightforward. So we just made our insert note resource, we enabled cores, and we added our post method, remember, and like now we're able to add a new note, and it'll get or if I put 6 explore items, so now it'll be added to our database. So we just made the resource. It's pretty straightforward. Nothing much to explain here. All we did was we made our resource, we specify the Lambda integration, which is our insert node underscore post Lambda function. So that's what gets executed when we hit this API endpoint. We added our integration request, which is the same as before. I made a mistake because I forgot this bracket and caused an error. but this just maps incoming data to the Lambda, to this event object that our Lambda function can use. Where is it? Here, this event variable that our Lambda function can use and easily manipulate. You can see here event.body, and we have the body here. That's what it's referring to. This .user ID is because in our code, that's how we send the that's the attribute name when we send our object. So user ID, node text. So by now that should be pretty straightforward, and we enabled cores as always, just to make sure that we allow the post request, otherwise we'll hit a cores error, we'll run into it. Like, if you ever get cores errors, just review your headers, your methods, and make sure origin is star. But star for testing purposes, you probably wouldn't put star in the production application. But for here, it's okay for learning and testing purposes. Star basically means any remote server can access our resources. So star is always the wild card. So moving on, we start coding our post request. So let's walk through the code. So here's the function that we added. Yep, that's the function. So starting from here all the way down is the function we added. So let's walk through this code. So this is the event listener for the add note button click. So remember, we have this add note and we gave this ID. So using this ID, it'll find the appropriate event listener. Now here we are getting the value of the note input field. So the big text box, we're getting that value because that's what we're going to insert. If it's empty, we alert the user as shown here. Please enter a note. Then we call our add note function down here to add the note, passing the value, our note text value, and then we clear the field after the note is added. So now let's dive into this big add note function. So this handles adding a new note right here. Here we retrieve the ID token from session storage. Next we split the ID token to get the payload part, which contains the user information. We decode the payload from base64 format to string, and then we parse the decoded string into a JSON object to access the user's details. So we extract the subfield from claims, which is the user's unique ID. Remember, they call sub as user ID. We convert the user ID to a string, then we generate a random ID for the new note. So remember guys, when we insert a new note, we insert 3 pieces of information. We gotta insert the actual note, but that whole, these lines of code that we just went over right now, we're getting the user ID of the currently logged in user using the ID token that Cognito gives us when a user logs in. And remember, it's different every time. So we got to get the user ID, then we got to create a node ID. So we do that with this generate random ID function that I made, and this is kind of straightforward. I create a random ID by combining the current timestamp with a random string. So that'll make our random ID. And then we got to send our AJAX post request to our API. So remember, this is going to be unique for every single one of you. If you don't remember, you can easily find it by going to stages. I called my stage prod. In this case, we're in insert note, go to post, you just copy this. This is going to be unique for you. Make sure you change it, otherwise your code will not work. And we would paste that here. And I mean, it didn't change for me because I already had it, but next we specify the HTTP method to send data to our server, send the JSON data. This is our JSON object. These are our attribute names and the attribute values. And if it's successful, we log the success message and we reload the notes page to reflect the new addition. So I call initialize notes again, which sends another GET request and will refresh the page, because we can only get that new note by sending another GET request to get the new note that we just inserted into DynamoDB. Otherwise we wouldn't get it. So we gotta call our initialize notes to do this GET request and do our display function again. So you got to do that. We just simply call that function here, and if there's an error with the request, we will log it. So I think it's pretty straightforward. Let's head on to the Lambda function and break it down. So we can zoom in a little. As always, we import AWS SDK. You need your Lambda layer, otherwise that won't work. We initialize the DynamoDB document client for interacting with DynamoDB. This is a little misindented. Here we define the parameters for the DynamoDB put operation to insert a new record. Here we must specify the table name for which we will insert the record. Here we extract and cast the user ID, node ID, and node text from the event body and convert them to strings. Here is our try catch block to use the put operation to insert the new record into DynamoDB, and here's the line that actually inserts it. If it's successful, we will return this object saying success, and if it has any error, we will console.log this error. So again, I don't need this. I return this event and it's not necessary, but I did it for debugging purposes. If you return the event, actually you ran into an error because it'll go to this catch block and then it'll return this, but whatever. I deployed that. So that is all for this add node functionality. It's pretty straightforward. Next, part 9, where we code the delete buttons functionality. So we're gonna code a delete request in order to make this delete button work so you can delete a node. And once we finish that, guys, you're in the home stretch, because you're then done all the big functionalities, and then it's just part 10 and 11 are super short and super straightforward. So once you code part 9, guys, you're basically done. And really, if you got to this point, guys, really give yourself a pat on the back. We're learning a lot about AWS Serverless. Stay tuned for the next video. Thank you for watching, and please subscribe. Okay guys, let's code this delete request. So it's similar to the previous step. Honestly, it's very similar, but we got this Lambda function is gonna be requiring a bit more explanation. So we'll get to that when we get to the explanation portion of this part. But as I mentioned, it's pretty similar. If you successfully completed the last part, you're gonna find this part is pretty easy. We're gonna make a new function. Go to Lambda, create a new function. We're gonna call this function delete note underscore delete. You can add that underscore delete because it's going to be a delete when we go to the resources. It's going to be a delete HTTP method which will send to API gateway. So I'll just create this, and in the meantime we will create a new resource. This time I'll create it under the root path, not like I did here. So we'll call this delete resource and we'll enable cores. Options, integration, wait, no, not yet. We'll first create a method, and we'll pick the delete, and we will copy paste this, the ARN AWS resource name. Make sure you, oh wow, why do I have two ever? And we'll paste that there. We'll hit the create method, and then we will make the integration request, same as always, but this time I won't forget a bracket. So we could hit the edit. Go to integration request and hit the edit, and go to mapping templates, add a template, application/JSON. And we go to the document, gotta find it, gotta find our integration request. Where is it? Oh, it's here. This time we will carefully copy paste this, and we will go here. And bracket at the top, bracket at the bottom. Man, that's a good job. Don't forget the brackets, guys. And I think that's it. Yeah. Because we're sending a delete request, and we're not sending any special headers. Yeah, so right now you're gonna see, oh, it already enables all the methods by default. That's good. So in reality, we shouldn't have to enable cores twice. So we should just deploy this API, hit prod. I've been doing it twice in these tutorials. I mean, it's not a big deal, but let's copy paste this. Actually, we'll need that a little later, our API endpoint link, and we are going to go down, going down to the new code. I'm sure some of you noticed earlier that I have this function here. When we make in the display note function, when we create the button for each new, when we create a button for each new node, we added it dynamically with this display note button, and we were modifying the document object model using jQuery and stuff. But if you notice, we also added this event listener which executes this delete note function, but we never added this function, we never made it. So that's what we're doing in this part 9. So we are coding our delete request to send the request to API gateway, and now we will fill out this function. So we're going to copy paste this entire function, and we are going to go here, not there, here, not there either. Man, I have 4 tabs open. So we can just copy paste this delete note function down here, and we're gonna go down and we're gonna copy and paste it. So we got this here. So it's pretty straightforward. It's honestly just an AJAX request, but I'll go over the code. Now you make sure that you replace this URL with your URL, or else it won't work. This URL is unique for everybody. So we copy this URL that we deployed and save that, and then we get to the next step of the function. Oh wait, I forgot. When we make our Lambda function, we got to do the 2 things, guys. We got to add a layer, add the layer that we've been adding. So I got to find my layer. Go to layers and go to layer 2, and we will copy this. Copy the ARN, or we copy it from here. verify, add it. And the second thing, we gotta add the permission because we're again doing operations against our database. So let us add it. We will add permissions, attach policy, DynamoDB, a full access, add permission, excellent. Now let us go to code, and we will now add our code. So, and there'll be, remember, we're going to need to change the name of our table, otherwise it'll be doing the operation against the wrong table. So we'll copy paste that, we'll walk through it, but we got to change the table that we are deleting from. Right here on this line, these are the parameters for our delete request. So we got to change this from notes v3 to notes v4, or whatever you named your table. I called mine notes v4. So you got to change that. You got to deploy this, and now watch. We can watch it. So let's delete these two oddball kind of things. So let's delete this. User ID string is not defined. Script.js. Let's walk through this. Delete note. Seems I pass in an extra argument that I never defined here. So it just seems to be the user ID though. So this seems pretty straightforward. I just gotta create this variable in this function to just gotta create this variable and pass it into delete note. I made a typo in the document. So here, when we call display notes, right here, I need to pass in a third parameter, which will be the string value ID. So we need to pass the user ID into this function so that it can be used in the delete note. So we will add this user ID string, and now watch, this color should change. So now we're passing it in, and now this will have a value. So we're simply making a small modification to display notes so that, okay, a display note will now receive this as an input. We'll have this as a parameter, the user ID, and this user ID will be passed every time we call this delete note function. And delete note needs the user ID. Needs this user ID so that it can pass this data to the delete to the API, and so that it can be used in the Lambda function. So now we save that. Let's try this again. It seems we are running into a CORS error. So I didn't redeploy, I didn't enable CORS. Oh, what was that? Okay. I didn't enable CORS, so we're running into that error. This is just easy to fix. It's weird that we're running into that error, but it's a simple fix. We just go here, we enable CORS. Hit the delete and options, wildcard, and click save. And we redeploy. because in the Lambda function, we're getting our data from the body, so it's no need for any sort of extra mapping of any sort. So we redeployed. Okay, second note should disappear. Let's try this again. And it is successfully deleted. And it's disappeared. Excellent. And we can delete this one. And another successful deleting. So, well done, guys. But now we have another step. Oh wait, no. First we gotta explain the code. And then we do the step 10. So I'm gonna go and explain this code step by step. What in the world did we do? So let's get that started. So again, I modified the code a little to accommodate for this user ID input. I must have made that change last minute, but it's all good. So remember, guys, we initialize notes, and when we call this display note function, this display note function creates a delete button with a unique identifier. So each of these buttons has the unique identifier, and that unique identifier is equal to the unique note ID. So the identifier attached to each of these buttons is the unique note identifier. If we inspect these buttons, if we do some inspecting of the buttons, if we go to this unordered list, you will see, guys, you see this note ID for number 3 is this 172522, and if we go here for number 3, 172522, 7HN, so that's how we made every button unique, because we need to know which button gets clicked every time we're trying to click. We don't want to delete the wrong button, the wrong record. So that's how we make each button unique, by giving it a unique ID. So now when a button is clicked, we're going to use this ID, and we're going to pass it to our API so that we know which record to delete, because we need to know which button got clicked. So this is the event handler for the delete button, the event listener for the delete button, and we get the note ID of the button that got clicked, and we input this into our delete note function along with the user ID so that we know whose note to delete as well. So we need which note and whose note, because you're going to see in the Lambda function the way it got coded, we need both of these pieces of information. Then we call the delete note button, and this is the function that handles deleting a note. So we send an AJAX delete request to our API. Again, this is unique for everybody. This is the endpoint. We're specifying the HTTP method, content type, our JSON object, the node ID, past user ID. This is the attribute name. This is the value. And on success, we do a nice console log, and on error, we console log the error. So this goes to API gateway, goes to the integration request, and will trigger our delete note underscore delete function. So let's head over there and walk through it. So as always, import AWS SDK, initialize DynamoDB document client. We filter this incoming data, event.body passed underscore node ID, event.body passed underscore user ID to extract the node ID and the user ID from the incoming body. Remember, body for the 50th time, body is from here in our integration request. Next, we start our try catch block to delete the item. So since we have both the user ID and node ID, we can directly delete the item from the table. So we specify our table, and we use the user ID as the partition key and the node ID as the sort key. So here it's basically kind of like querying in SQL if you're familiar with that. So we're just telling which user, delete where the user ID is equal to our user ID variable, and where the node ID is equal to the node ID variable. Next, we perform the delete operation on our DynamoDB table. If it's successful, we return the success message, and if there's an error, we return the error message. So that's pretty straightforward, I think. And that's the delete functionality. But now we got one more thing to do. How do we log out? We log in, but how can we log out? That's going to be in our next tutorial. So we can delete one of these 5s, and you'll see now when we refresh, there's 2 5s. One of them will disappear. Everything is working great. Now guys, we're almost done. It's like, seriously, like, look, the document is, we're at the bottom. We're at the bottom, guys. So we're almost done. We're just going to code the logout process. In fact, I'm going to just do it now. It's just adding one button. It's so simple. Let's just code this now. Actually, I'll code it next time. Yeah. So next time we're going to code the logout process. It's really straightforward. It's just CSS and this little event handler function. So where we just basically we clear our session storage to remove the ID token that we store when a person logs out, and then we're going to host it on S3. So stay tuned for that. Thank you for watching, and please subscribe. Let's code the logout process. This is part 10. So as always, we code it and then we explain it. So we'll add this button to index.html. This is pretty simple. Button is button, and go to index, and we'll just add this button at the top of the body. Save that. Let's see our new button, and now let's make that look a little nicer. So I added some styling code here. So let's style this button, and the styling is the styling. That's also just pretty straightforward. We will go to styles.css, and I'll add the styles down here below this h1. We'll hit save. We will go back here. There we are. Have a little nicer button, nicer looking. So, and finally we will handle this event. Add this event handler for this button. We will go here and we will go to script, and we can just add this anywhere. Let's just add this at the bottom. Let's just break down this event handler. So remember guys, we're using session storage to store the ID token, which is what we use to get all the data. Tokens can expire. So just to give you an idea, because I think most of you have experienced this, it's like when you log into your website like YouTube, Gmail, whatever, after a certain time you might get logged out by yourself. By itself it logs you out. So that's the token expiring, and it'll ask you to log in again. So that's basically what we're doing here in Incognito. It generates tokens, and they will also expire after some time. And we're storing these tokens in session storage. And to see it, we go to more tools, developer tools, and we can go to memory. Storage. And we go to session storage, and we see ID token. So that's the token that we've been storing. So we just want to delete that. And even if you go to YouTube, so I opened up my YouTube, and you can see here a bunch of stuff in session storage gets stored. So we got no clue what these are. So we're gonna just delete this, and we're gonna just redirect them to the login page, and it's gonna be pretty simple, because once we delete this, it can't reuse it to get all that data. So we clear the session storage, and then we redirect to signup.html. So You can clear everything also, but I just clear ID token to keep it simple. So we save that and we're gonna now log out. Now see, look, there's nothing stored here, but here's the key. If we go to index.html, nothing will show up because we have no token. Nothing, we sending a GET request, but nothing will appear because we don't have that user data. So that's how we code our logout process. And it's pretty simple. We just added that event handler function. We added a little CSS. Now we can log in. We can do our whole process. We can make a new user. I don't even know. What did I click there? Okay, we can make a new user. We can make Pat. We can make Patty can be our new user. You'll just go with the same email that I've been using. He has the same password, just for simplicity. We registered him. Go here, verify Patty's code. Here, confirm him. Now he can log in with this password. Log in, not now. So he can make his grocery list. We can have some apples, some grapes, and some, I don't know, flour. Now he has his grocery list. He finds out he doesn't need grapes. He can then log out, and then Will wants to use this app. He has the same password. Now we see our previous notes, and this is completely working. Now he doesn't need number 6. He only needs to remember 3, 4, 5. Oh wait, Patty needs to log in again. He can log in, and this is all using AWS services in the background. You saw it, all these serverless services, but now it's the final step. We can add one more. We can add rice to Patty's list, and you see it saves it it'll display it just as we save it. We can take this, but this is just on our local machine. We want everybody in the world to be able to use our Notes app, and that's what we're gonna do in the next part. We're gonna host our website using S3. So we used only CDNs in our code, so we didn't import anything. We didn't have to make any big library. So this is gonna be really easy, guys. You're gonna see making our website available and hosting it through S3 service is going to be super straightforward. Look, see, there's just such little instructions. We're basically done. So we're going to go through part 11 in the next part. Thank you for watching. Congratulate yourself. You learned a lot. And I will see you in the next part. Please subscribe. Okay, bye. Okay guys, let's finish up this project and host the website through the AWS S3 service, making it public for everyone to use. So let's get started and go to S3 and make our new bucket. So we're gonna need to make sure that this bucket is publicly accessible. And also make sure that we make the policies in a way so that the files can access each other, because if you look here, the index file and the script file and the CSS, they all need to be able to access each other in order to work and have access to the functions and access to the styles. So we need to make sure that we make our policies appropriately in order to enable that access. So we're going to call our bucket, and we got to make sure that we create the policy after and make our website public. So we're going to unclick this. We're going to want public access because we want people to visit our site. Disable bucket versioning and click create bucket. Click I acknowledge, that's fine. So next we go to our bucket, notes v4. We're gonna upload all of our files, click add files. Actually, before we upload, let's modify the permissions. So we allowed public access, and now we need to copy paste this policy. So we'll go here, go to here, and copy paste this policy. So let's just break down this policy a little bit just so that we can get a little understanding. So this is the version of the policy language being used. So this is the main part of the policy. It contains a list of one or more statements that define the permissions. So each statement within this will grant or deny specific actions. The statement ID is a unique identifier for this specific statement. And in this case, public read get object is a descriptive name that indicates this policy allows public read access for get object. Next, this effect allow determines whether the policy grants or denies the specific action. Now this is the big part, this principal. This principal specifies the user identity or identity to which this policy applies. So in this case, this star or wildcard means this policy applies to everyone. This effectively makes the bucket objects publicly accessible because it allows anyone on the internet to perform the specified action. In this case, this star means that the policy applies to everyone. So in this case, the action specifies the AWS operation that the policy allows or denies. So these are the actions that this policy will allow or deny. So in this case, the action is S3 get object, which means retrieving an object from the S3 bucket. And here, the resource defines the specific AWS resources that this policy applies to. So all of us need to change the bucket, change this from your bucket name to the actual name of the bucket that we created. So notes v4. So click Save Changes. And now we will upload our files. So upload, go to the folder where you did your project. And we're going to just upload all of the files. You don't need to upload the Lambda layer. Just upload your individual files. And we will hit upload. Now the final step, and then this thing is deployed. This thing is public. We need to enable static website hosting. So enable it, and we need to point it to our signup.html because that is the page we want the user to land on when they first get to our page, get to our website. So click Save Changes. Scroll down, copy this. We can open the private browser and we can see this working in action. Oh my God, guys. Our website's working. We can log in as Will from before. We can get our password. Log in. And we'll see all of the notes Will wrote, 3, 4, 5 from before. We can add a new note, 7. We can delete 4 if we want. We can then log out. We can log in as Patty. If you remember the grocery list. Everything is working. We have a fully working application statically hosted on S3. Well done, guys. We have learned so much about AWS services. If you got to this point, you should really be proud of yourself. We can add another item to our list. Let's add cake because we can celebrate. And we need, if you've made it to this part of the tutorial, guys, seriously, well done. You guys should be proud of yourself. We learned so much about AWS serverless services, and thank you so much for watching. You can see everything is working. If we go to DynamoDB, we got those new records, cake and 357. The 4 got deleted. We can log out. We can log back in as well. Everything is working beautifully. Guys, if you made it to this point of the video, please subscribe, please show support, please like. It really encourages me, and you guys should be proud of what you've built today. Thank you for watching and have a great day.